Hey everyone, good morning, good evening, good afternoon, wherever you are. So today we will be discussing this paper called Refactoring versus Refactoring that was published by this company called CodeScene that builds products, AI products that help um, software development, right? So I'll be starting off with my introduction and then we'll see. We'll go along with the paper. What is refactoring? We will be getting getting to that in a bit. Okay, let's go. So basically, just a simple introduction about myself. I'm a staff engineer with over 10 years of experience in software development. I've worked in various industries like industrial automation and healthcare and consumer IoT. I've worked for the first 5 years. I worked in big corporations like Schneider Electric, Siemens Healthcare, and all. And the next 5 years, I've worked in complete startups, healthcare and IoT based startups. So I basically love building products, software products from the ground up, and even revamping existing products to take them to the next scale. So that's my experience professionally. Apart from that, you would probably see me playing badminton during the winters here in Toronto, and you'd be see me playing cricket in any of those free baseball grounds in summers. So that's about me. Okay, so we have a lot of ground to cover today. So basically, we'll just be going through what code refactoring is for folks in the call who don't, who are maybe new to the industry, entry level engineers, or who don't understand what code refactoring is. And then we'll explore something that's called code health metric that this company CodeScene has come up with. That is kind of a proxy for quality of code. And then the reason we explore that is because the performance of these LLMs uh, are kind of gauged with respect to code health. So, sorry, I think I missed introducing what the paper is actually. So, what this paper discusses about is the performance of the current LLMs on code refactoring tasks, right? We all know that there are tools and chatbots and that exist like ChatGPT and Perplexity and stuff like that that are capable of generating new code based on human prompts, right? But how well are these LLMs actually equipped to actually do code refactoring? Because the senior engineers on this call maybe can vouch for this that at least 70 to 75% of an engineer's time in a company or the team is spent on code refactoring compared to building new code, right? So that's why I was interested in this paper, because if AI is actually capable of doing code refactoring as well, that's when we have to be looking at next level skills to develop as software engineers. So basically, we're trying to answer the question if we are there to completely readily say that software engineers can completely be replaced by AI, right? So that's what we'll be checking next, and then we'll explore as to obviously we all know that there is some level of error with AI. So we'll try to understand how and why does AI error as well. And finally, after that, we'll be exploring something called a fact checking model that built by CodeScene to overcome the shortcomings of the current out of the box LLMs that are available on open source platforms like Hugging Face and others. So this is what we'll be exploring today. And I will be pausing between each major section if you guys have any questions or have any inputs yourself, because this is a research paper, and let's keep this session as interactive as possible. I might as well I will also be able to learn from you guys. Okay, let's jump into it then. Let's just start with code refactoring. What is code refactoring, right? Basically, code refactoring is working on existing code to improve its design, improve its performance, improve its efficiency or efficacy, all of that. Uh, the reason this is important is almost all companies, well-established companies, have pretty extensive code bases of their product or service or whatever they're offering, and that code base continuously has to evolve for changing business requirements, for growing business conditions, and stuff like that. Uh, so to keep things simple, we'll just consider it as, if it's not refactoring, if we fail to quote unquote improve the design of the implementation. The reason I say quote unquote is improve is a very subjective term, right? It can be a 10% improvement, it could be 90% improvement, again based on multiple factors. We'll be discussing a few of those major factors in this paper today. And this, I believe, this is the most important definition. We fail to preserve, if we fail to preserve the original behavior of the code, then it's definitely not refactoring. Because refactoring means updating the existing code to make sure that the code is better, but the behavior is same. And if we fail to preserve that, that is what this paper refers to as refactoring, right? So it's basically a wordplay of refactoring and the F word. So basically, yeah, the process of modifying existing code while voluntarily or involuntarily altering the program's behavior. So we'll consider this as the word to describe updating code with changing behavior. Okay, now that we know what code refactoring is, let's kind of explore what code health is. All right. Uh, I mean, code health in generic, you obviously it's so pretty self-explanatory. It tells what the code quality is and stuff like that. But CodeScene went to a detailed level of analysis to come up with this metric that tells if the code is good, code is okay but has some risks, and code has some. Oh, sorry, I thought someone joined. Yeah. So, what is code health? Code health is basically just a metric that they claim that has proven business impact in terms of post-release defects and velocity of development. Basically, it's a measure based on factors known to make code harder to read, harder to understand, and harder to maintain in the long term, right? So yes, this is actually a screenshot from a previous white paper that CodeScene published. The link for that paper is here. So this paper basically has a complete detailed analysis of how they came up with this code health metric. Why is it actually considered important, an important proxy for code quality? Like you see here, it's an aggregated metric of about 25 plus different factors. We call them code smells in the programming language, and like they claim here, they are known to be correlated with increased maintenance costs and increased risk. To put it in simple terms, the CodeScene has built a CodeScene tool that that comes up with code health of each source code file, right? So basically, the source code is put into the tool, it's parsed, and they look for different kinds of code smells in the code, and they then categorize the files into healthy, uh, okay with yellow, and definitely red, meaning the code is not safe and it has significant risks, right? For folks who don't understand what code smells is, I can give a couple of examples. For example, you see god functions here, right? So basically, god functions are those functions that are doing way more than one task. Uh, in object-oriented programming, we have something called solid principles, and the S in solid principles refers to single responsibility, meaning each entity in object-oriented programming has to perform one single function, one single operation based on the context. The class should have one purpose, the method should have one purpose, each object should have one purpose, and these functions usually are those that take on way more than one function should. Just to give an example, I had in my previous company, basically there was just one single function that did the whole operation of the whole class, and that single class was like the service that was exposed as an API. And it was hell trying to detect issues. It was hell trying to optimize the code. It took months to even understand parts of the code. So this is one code smell. We can Low cohesion is the exact opposite of uh, good functions. Low cohesion god functions are almost similar. Anyway, so yeah, for this talk, we are going to go with the assumption that code health is a trustable and a reliable metric that decides that tells us if the code is healthy or okay or absolutely unhealthy. So before we jump into the performance of LLMs, are we clear of what's discussed so far? Do we have any questions, or does anyone else have an experience with code smells and want to share their experience? Okay, I take that as everything's good. I'm an optimist. Okay, so let's see how the state of the art LLMs that CodeScene tried with performed on code refactoring tasks. I should say the then state of the art LLMs. The reason I say the then is because LLMs have progressed a lot since the time this research was performed. So basically, they checked the performance of LLMs on. Uh, before we talk about what LLMs were what LLMs were checked on, let's see how were they performed. Basically, what CodeScene did was they collected over 100,000 real world samples of code that clearly had code smells, and the way they detected that was also using their CodeScene tool. So they for sure know that these samples had code smells, and then they performed code refactoring on these code samples using the popular LLMs. Again, I'll just take a step back for folks who are new to this AI world, or are new to the tech industry. LLMs are basically large language models. For any of these new chatbots that you obviously are aware of, like ChatGPT, Perplexity, Bard, etc., have an underlying model that is doing all the work of the text generation that we see, right? So different ChatGPT uses GPT 3.5, GPT 4, and each chatbot has its own underlying LLM. So there are open source LLMs available as well. Like for example, Facebook has made Llama as released and open source, so anyone can actually access Llama for performing LLM based operations. So yeah, basically CodeScene performed. Yeah, go ahead, Raghu.
I was just curious, is CodeScene similar to Sonar Cube? Like, does it do something similar to what Sonar Cube does, or it's completely different in terms of offering?
That's a great question, but I don't know the answer. Maybe you can tell me what a Sonar Cube does, because I don't know, and maybe I can then tell you what CodeScene does.
Okay, so Sonar Cube is usually it does a lot of your PMD health checks and also CodeSmell. So we can write specific rules for the
Mhm.
Sonar Cube, and then it's usually sort of kind of integrated into the CI/CD pipeline. And then when we build our projects, like whatever, it's a Gradle,
Awesome.
Maven,
Okay.
and then it kind of the rules get applied on the code, and it usually tells us, hey, like less unit tests, or these are the code smells, and so on and so on. So it sort of gives more or less like a report. And
Interesting.
yeah.
Awesome. Thank you. Thanks, Raghu, for that insight. So, CodeScene does something similar, but not exactly the same. CodeScene goes a step ahead. CodeScene comes into picture even before the CI/CD, as far as what I know. It's like a co-pilot for you during development, and it also just recently they released a video just 6 days back. I can share that video after this talk, where their tool, even on one click, does the refactoring as well. So it's before even the CI/CD pipeline kicks in, uh, and they basically build tools to not just check the code smells, but also perform the refactoring on the code. I hope that answers your question.
Yeah, thank you.
Awesome. Okay, so and then the AI models performed the refactoring, and they evaluated the results. So basically, how CodeScene evaluated the results were based on two things. Automated tests are very standard in any software development practice. Tests already exist, and after any implementation change, we run those tests even manually to see if anything broke. And the other thing that they did was reassessment of the code health, right? Initially they used the CodeScene tool to make sure that these samples had code smells, and after the AI models performed the refactoring, they uh, again did the code health assessment on the refactored code, right? Before we actually get into the performance, I want to give a little more detail on the data set that they use. Basically, they just use JavaScript and TypeScript code. Uh, they do say that they understand different languages perform differently, but they chose these two to start off since they are almost topmost in the in popularity wise, and also community support wise online. And also they just focused on four major code smells that we usually try to fix in refactoring and even during our code reviews: complex conditionals, deep nested logic, bumpy road, and complex methods. I guess these terms are pretty self-explanatory, but if anyone wants any explanation on any of these code smells, let me know. I'm happy to explain. If not, we can actually go and see how these LLMs performed on code refactoring tasks.
What do you mean by complex methods?
Complex methods is exactly what I just mentioned previously. They're equal to God functions, doing way more than what they should do. And complex methods kind of can include complex conditionals and deep nested logic. Methods having multiple if else conditions, each if else condition having multiple checks within that condition. It's hard to understand. And it's a combination of all of this, right? Long method, including complex conditionals and the deep nested logic as well. And bumpy road again is like, it's just like an informal term. It's like a combination of other small, not majorly known code smells. For example, it could be using magic numbers, right? For example, let's say your logic is doing some math operation, and every input is being multiplied by some random number, and there is no description as to what that number is, or that number is not even declared as a constant. And this is hard because if anyone new is coming into the code base, they don't know what that is. And it's going to take a lot of time to even debug and try to understand the math behind it and stuff like that. This is just one example, but yeah, bumpy road is mix of these kind of smaller code smells. Okay, so let's see how these LLMs performed, right? So, like you see, I think they did this research sometime in the month of around May, June, or July of last year, and that's why these are the four models that they kind of they allowed the code refactoring to do: Palm 2, GPT 3.5, Palm 2 trillion, and Fine Code Llama with 34 billion parameters. And once the code refactoring was done, they checked if the code was valid, if the syntax was right. So there was no shocker that the syntax was almost right, because these LLMs are pretty proficient in generating code. But did the code health improve? Right? Did the changed code mitigate the code smell? Like you see, it did not do exceedingly well. It did okay with the highest. It did better, yes, for sure. It did better than nothing. With Fine Code Llama being the best performant with about 78%, and the others around 60, late 60s. But again, having said this, the even more important thing to check if code health was improved or not, it's okay. But did the behavior change? Right? Was the refactoring semantically equivalent to the original code? What I mean by semantically equivalent is uh, the refactored code's behavior should be exactly of the behavior of what the code was before refactoring. And that unfortunately was not that great, right? Like you can see, uh, Fine Code Llama was like having an abysmal 18% test case passing, right? So basically, the refactored code introduced more bugs and completely changed the not completely, but yeah, 37% to 18 to 37% with change in I mean success rate. So that clearly shows that using out of the box LLMs for code refactoring tasks is pretty bad. Uh, to completely depend on that, right? And also, they did an external validation. This was the study that CodeScene did, but they also compared their results with another 2023 based study that kind of uh, checked the functional correctness of code generated by these AI tools like CodePilot, Code Whisperer, etc. And apparently, even those tools gave only a correctness somewhere between 31% to 65%. And this was not even for code refactoring. This was for generation of new code, the correctness of generation of new code, and that's why we have a higher end of this percentage here. But if you see there, low there the higher percentage of refactoring kind of aligns with the lower end of generation of new code. So they kind of uh, validated their experiment to see if they were assuming things or they have some meat in what they're saying. And of course, generating new code is simpler than refactoring code, even for a developer, right? We always prefer to write start a new project or write new code if given a chance. So yeah, so this I've linked the paper of this 2023 April, I guess, study as well, where few, I think, engineers and a couple of data scientists perform this experiment to check the code quality of these AI assisted generation tools. And if you observe, we did not discuss they did not discuss about GPT-4 yet, because GPT-4 came later during their experiment, and they kind of did a small benchmark on GPT-4 as well, and they kind of saw that GPT-4 performs slightly better, but even then, the whole on an overall aspect, they're kind of offset by GPT-4 being significantly slower than 3.5, and also they saw that it was a bit expensive uh, than GPT 3.4. So this is how they kind of validated and saw that code refactoring obviously has still more work to be done on the AI front, right? So before we get into the next stuff, so does anyone have any questions, or does anyone have anything to add? Please feel free. Let me check the chat 1 second. Okay. Okay. I guess we're good. The next thing we'll try to see here is, before getting into the solution that the code scene came up with, let's see how actually does an AI error, right? What CodeScene came up with their research is LLMs, or again, there could be LLM experts in this call. They can maybe add more or correct me if I'm wrong. According to the paper, at least, they claim that LLMs don't have a concept of correctness, right? Basically, few tokens have more probability of being generated than others, based on the weight, based on the fine tuning of the model that whoever is doing the experiment has set. Uh, the AI also, after generating the code, it doesn't necessarily execute the code, right? It just generates, just like text generation, it generates code as well. And it doesn't execute, nor does it prove the correctness of its generated code in any quantifiable way, right? So the problem is because the nature of programming is way more constrained than just generating natural text on human response. Let me give an example. While generating natural text, choosing one synonym over another is fine when you're trying to answer a question for someone. Using one synonym over another has zero to low impact uh, if the meaning has no meaning does not change. But that is not true in case of programming, right? Even a removal of single character can cause the code not to compile, and uh, rearrangement of variables can change the whole logic, and there could be so many things that can go wrong, and that's why they say that the AI errors. And they also have an example here, so let's just briefly look at this example. Let's not spend too much time on this, but here on the left there is a code. This is still not a god, I would still not call this a god function, but this is a function that kind of has a lot of nesting, right? So there's a for loop inside which there's an if condition, inside which there's another for, inside which there's another if, and outside again. So there's a lot of nesting, and there's like complex checkings as well. Checkings are not that complex, but yeah, they tried refactoring this code with AI, and they, like, on the right side you can see the refactored code. Basically, they merged all of this. The AI put all of this part of the code into this method called update stack, and the red highlighted part into update max method. And like you can see, this is a JavaScript code snippet. And in JavaScript, the primitive data types are always passed by value and not by reference. What I mean by that, for people who don't understand pass by value and pass by reference, is the value of this variable inside this method is limited to only the scope of this method. So even if, let's say, at this point, uh, we are sending 30, at this point it's 30, and if max length is something greater than 30, max depth can be updated to, let's say, 40. But this 40 value is not propagated back to the parent method. So when the execution of this method is completed, it gets back here. Max depth is still 30 because 40 is lost inside this. And AI just could not understand to that nuanced level that it's passed by value and passed not passed by reference. And once this refactoring is done, this kind of minor bugs in terms of code, but very major in terms of the output, can we can easily oversee them during code review. Maybe the software engineers can vouch for this as well. So yeah, anyway, this is how an AI can err. Now let's actually move on to see the fact checking model built by CodeScene, unless anyone has any questions up until now.
Pratik, I have a
Yeah,
question.
yeah, sure.
So these benchmarks are on the generalized LLMs, right?
Yes,
What
correct.
if we do have specialized LLMs for code generation and all those things?
Uh, when
How
you
they
say
perform here?
when you say specialized, do you mean like uh, can you give an example, maybe?
I'm not pretty sure about it, but the LLMs which are just trained for code generation purposes
Right,
and
right. So
have,
these are the
yeah.
ones, right? Give me just a second. So these are the ones that were popular for code generation when they performed this experiment, right? Now Google's Gemini is way more capable than uh, at least Palm 2 and GPT 3.5 is what I think. And there's another open source LLM called Mistral that allegedly performs better in terms of human eval and stuff. But with respect to code, I don't know. I don't have the data. Like I said, this paper talks only about these popular LLMs that were there back then.
Okay, Pratik, thanks.
Yeah, yeah, no worries. So we finished this. All right. So yeah, since the out of the box AI models did not perform well, what the code scene team came up with was actually a layered model. Before we get to the layered model, what let's see how they actually started the experiment. Basically, what they did was they used the same Gen AI tools using the models that we just discussed. So they told these LLMs to come up with a bunch of solutions for each of those 100,000 samples that they had, right? If you remember previously when they benchmarked it, each LLM, I mean, each file was refactored just once and then they just measured it. But now and we all know that refactoring can be done in multiple ways. Each developer refactors code in a different way based on his experience, based on his skills, and etc. So what they did was they asked the Gen AI to refactor each file or each sample with multiple solutions, and then their fact checking model would reject all the wrong ones. So basically, each of these refactored files will go through this fact checking model. First, the model will check the syntax, and if the syntax is valid, only then go to the next one. If it's not, it's discarded. And then obviously they have the code health advantage, so they'll check if the code health is improved or not. If it's not, then there's no point in that refactoring, so reject it. And finally, they check for semantic comparison. Again, what I said, like I said, they're checking if the refactored code has the same behavior as that of the original one. And if it is, then they're labeling it as high confidence with about 98% precision. 98% precision is what they found in their experiments. I'll again go deep into that in the next slides. And if the semantic behavior has changed, then they tried with some minimal refactoring, not a complete refactor of the code, but some minimal refactoring. And if that kind of passed and semantically was same, then they were like, yeah, we have some amount of confidence, but please review the code before you apply these changes. But even after minimal refactoring, if semantic difference was there, then they were just discarding it. So basically, they did this whole fact checking for each refactored file. So you can see that they started with 100,000 code smells, right? Each code smell, each for simplicity, let's say each sample was one file, and each file was generated with these multiple solutions. That's like, let's say, 6 solutions they came up with. So it's like 600,000 samples went through this fact checking model. Uh, we in the coming slides we will actually understand how did they actually perform this fact checking, but this is the top level uh, design of their layered architecture of fact checking. And once they did that, they benchmarked the code smells. Basically, they just showed the uh, code health metrics of rejecting wrong refactorings and keeping only the correct ones with respect to what GPT 3.5 did, right? So with respect to complex conditionals, this fact checking model basically did well with about 96% efficiency, with deep nested logic with about 98% compared to about 26 here in GPT. With bumpy road, again, it's about 97 to 26. And with complex method, again, close to 98% to about 28 compared to raw GPT, right? What does it actually mean? Basically, what this means, let's say the average of all of this is about 98%. Uh, what this essentially means is, out of the pool of solutions, that 600,000 pool of solutions that these ALLMs generated, the fact checking model was successful in eliminating 98% of wrong solutions. So there's still a chance of 2% with wrong solutions, but that is still way better than a human refactoring, according to study. When even an intermediate to senior level programmer refactors, there is still a possibility of 20 to 25% of failure compared to 2% here. Uh, this is way better, right? And that's what they claim here. That's what they're showing here. So initially, the initial AI performance was what, 30, correct 37%, but with rejecting all the wrong ones, they show that even the refactoring, uh, AI generated refactoring, they were able to filter out with 98% efficiency. CodeScene claims that they had two unfair advantages to achieve this kind of efficiency with AI generated code refactoring. One is that they had the access to their data lake with over 100,000 code samples, code refactoring samples, along with the known ground truth, meaning they had the original sample along with the refactored sample, right? And the second advantage that they had was, this is kind of like a prerequisite for the first advantage, meaning the data lake was built up using the automated code review feature that the CodeScene tool had. Like I mentioned, I've not explored this tool yet. This is actually a tool that they've released. It's a paid tool. They have a free version as well, but I just couldn't use it. Uh, Apparently, this tool has code review capabilities, and using that, which is again proven, and using that tool, they were able to validate the data that they had in their data lake, because, like we all know, AI is as good as the data that runs on it, right? Uh, I know how just having these 2 points as the core for the fact checking model might not make enough sense. I will explain a little more in detail with a nice component diagram. But before we move on to that, does anyone have any doubts or questions? Or even if you want to add something to this?
Could you kindly go over the first unfair advantage?
Yeah, sure. About this, when they say unfair advantage, they, like I said, they had the 100,000 plus code smell samples, right? How did they get that? That's the challenge that anyone would have. So they claim that they got that because of the capabilities of their CodeScene tool, and they had access to that data. Data is the main thing for training the models, right? That's what they mean by they had their unfair advantage of a data lake with 100,000 code samples with code smells. And they also had the samples, right? They ran the AI initially to refactor the code, and they checked the benchmark, the initial benchmark, and they also had that refactored code in the same data lake. And I think this is the right point to maybe next talk how they actually uh, train their models for uh, this fact checking. So, like I said, they started with these code samples with code smells, and they refactored the code. And this part is basically the initial benchmark that I showed you. And once they refactored the code, they stored the refactored code as well that was generated. So basically, this whole data lake now has the original code, which has the right behavior but has code smells, along with all the code that was refactored. And in the initial benchmarking study, we saw that in the refactored code, around 63% to 82% was invalid because they had the probability of 18 to 37% of valid refactoring. Meaning this part of the code in the data lake that you see, we know that the code was properly refactored as well as they were semantically correct, meaning the behavior did not change. So meaning this is a valid refactoring, right? So this part is the unfair advantage they're actually what they're referring to, because now CodeScene had their infrastructure to work on these. Basically, before even their models got access to this, what they did, according to the paper, was they reviewed and validated this code using their code review tool in code review feature in that code scene tool, and made sure that this actually is valid. That's how they came up with this number. And once they were sure of this, now they made the code scene algorithms in their fact checking model continuously learn patterns in the successfully refactored code, right? Meaning to basically to sum up, the blue block that you see here, the code scene algorithms, is nothing but the chunks of these fact checking models. That's how they were able to kind of reject and accept solutions based on the patterns that they learned, that their model learned on this valid refactored code. Because when they were these models, when they were validating these refactoring codes, they were obviously checking it along with the original version that they had here. And this code is guaranteed to be semantically correct and better code health. And that's what they basically did. And they have not published details of unit tests after performing this valid refactoring code, but in the paper they claim that they were semantically absolutely 100% equal. So that's how they validated that this fact checking model of rejecting uh, basically this fact checking model of rejecting wrong solutions and having accepting only the proper solutions with the aid of their CodeScene tool and their inbuilt AI models, they were able to generate uh, proper code refactoring using AI without human intervention. And again, it's the most intriguing possibility that they talk about is the progress with technical debt that teams can go through now. Uh, some huge companies have teams dedicated to only mitigate the technical debt that was built over the years to support uh, scale and growth of the company. I hope that answered your question to some extent, at least.
I mean, you have, firstly, thank you for that. So I'm just trying to understand, we said that code scene has a 98% accuracy.
Mhm.
It refactors quite well. But in the summary, we say that it's nowhere near replacing humans in a code refactoring context. Like that sounds like contradictory statements. Like,
Yeah,
can you
yeah.
help me?
Oh, yeah, sure, sure. So basically, the current AI models, maybe I should replace this word instead of AI. I should. It's still AI only. What I mean is, what they mean is, you can't just take an LLM existing that can generate code and tell it to refactor code. That still doesn't exist. Uh, what CodeScene is actually doing is still using those AI models to refactor code, generate multiple samples of refactored code, and then out of that pool of samples, the fact checking model of CodeScene is rejecting all the wrong ones and storing only the uh, right ones, right? So this study basically shows that out of the box LLMs can't refactor. Maybe not, maybe shows that AI is nowhere replacing, maybe not the right way of saying things. It's a study that shows that existing LLMs cannot completely replace humans in the context of refactoring code. Not And CodeScene is also not has not built any LLM that is refactoring code, right? If you see this, sorry, if you see this, CodeScene also is not building any LLM. It's basically just built an AI model that can reject wrong solutions. And with that, they say that they have 98% accuracy, meaning they're 98% effective in rejecting the wrong solutions.
But doesn't that give us the right solution then?
Yeah, it does. It does give us the right solution.
Yeah.
Yes. Oh, you
Like,
mean this statement is
like
contradicting?
I'm just trying to, so my main key takeaway from this,
Hmm.
entire session is
Hmm.
it like, is code scene good? Is it bad? Like,
Oh,
because
yeah. I mean, CodeScene, they say they claim it to be good. Again, I'm not any brand ambassador for CodeScene or anything. I just found this
okay,
paper to be interesting. So
appreciate the honesty.
yeah, yeah, yeah. But to answer your question, they claim it to be good. Again, that's a good question actually. Like I mentioned initially on the call, I'll share this video that CodeScene published just about a week back, where it's like a copilot uh, that's like a plugin to your IDE, and basically they are using this particular fact checking model that we discussed here, and the tool does refactoring, but still the developer still to get some confidence, you need some experience using the tool, which I don't have.
I understand. Well, thank you for your insights. It has
Yeah,
been a
for
very
sure.
educating experience. Thank you.
Yeah, thanks, Hassan. I guess that's all I have. So does anyone else have anything to add or even questions I can take? I'm sorry if I've not been able to answer in detail of any of the questions I've previously asked, because my knowledge is just limited to what's disclosed in the paper, and in the paper that's what they have right now.
I have a few questions for you.
Sure, sure, Raghu.
So again, I'm probably coming from the engineering standpoint. So
Sure.
The data that they've used
Hmm.
for running it, um, this was the source like just open source projects across multiple languages, or did they kind of scope it to specific projects and specific languages?
Yeah, for sure. I think I mentioned that initially. They limited this study only to JavaScript and TypeScript, because they know, again, they know that different languages perform differently, might perform differently. So they just limited the study to start off with JavaScript and TypeScript, because that's one of two of the very, very popular languages. All, and they also have a lot of community support to for their models to refer to. So that's what they did. And to answer your first question, they have not mentioned anything as to whether they were open source projects or their own code or their client's code or whatever. I don't know. I'm guessing it should be open source projects with proper licenses, MIT license or Apache licenses that can be used uh, for their uh, study.
Got it, got it. And another question is,
Hmm.
again, it's a little bit more generic as
Yeah.
such. Um, when we are having such tools, right, like AI tools and stuff,
Hmm. Hmm.
uh, like what is their goal, like, of adoption in the companies? Because some companies, they are a little wary of exposing their code base and giving it to some external
True.
tool.
Yeah.
So what's the kind of trend, or how do these tools look at being like in terms of adoption and getting them into an organization?
Yeah, that's actually a great question. It it's sometimes highly dependent on the industry. If it's a highly regulated industry, then companies will be wary of using such tools. And some tools kind of have they confirm that they don't read your code, or they don't store back their code in their server or anything like that, which again, if it comes down to the trust factor. CodeScene is a very new company, and they're doing this as like I think they've just raised about $8 million so far in series, or in the seed round or series A round. So it's a good question. If you ask me, with my experience, I don't think, at least Siemens Healthcare, I don't think would have used these tools, because healthcare data is like, if you know, healthcare companies are the most protective, if not financial, if not equal to the financial companies. Financial data and healthcare data is what more companies would find it a little slow for adoption, but startups will jump on it right away. I can give that in writing, because startups right now, they don't even have enough clients or customers data to protect, right? So they're in hyper growth mode, and for growing faster, these tools, for sure, I can at least say with my experiences, these tools help a lot in accelerating that growth, at least with respect to software development.
Yeah, I kind of agree to that, because I've been on both sides where, on the financial side, we were
I see.
extremely wary, where even to bring in a cloud vendor,
I
because
see. Wow.
a lot of data kind of, kind like resides
Yeah.
in the data center and the
Right.
protected it. And, being on the other side where we just adopt whatever comes and bring in this. So I
Yeah.
can relate to what you're saying.
Absolutely. At least in my previous startup, I was the only backend developer, and there was one front end developer. We both used completely different tools for our developments, because the management doesn't care as long as you're actually moving fast, right? And on the other hand, I was working on in another healthcare based company. It was a spine surgery based company, where, like you said, they were hesitant to get in a cloud provider, right? I mean, this company does. By the time I joined, the product was already designed and stuff. The way they designed it, they did not even have an internal server or storage, right? Basically, the design was such that all the data that are gathered for that particular patient is stored locally in an Android tablet that is used during the surgery, and that was a level of concern that these companies have, for sure. Yeah, I agree with you too. All right, if we do not have any more questions, I guess that's all I have for today. Thank you everyone for joining. I will be sharing this. Thanks, guys. I will be sharing the recording to Rahul and Alex, and they will upload it uh, on Taro.
Thank you,
Right,
Pratik.
guys. Thank you. Thank you,
Thank you
Sam.
so much. Have a good
Thanks
one.
everyone for joining.